Hello, my name is Harsh, and I will be the host for today's community meetup, where we are going to talk about how you can get started with ephemeral environments on LocalStack and how you can build AI powered applications using LocalStack and Ollama. So, just to take a quick look at the agenda today, first off, we are going to have an intro and welcome. Second, I'm going to quickly walk you through all of the recent things that we have released out in LocalStack 3.7. LocalStack 3.7 is our latest release that we have just got out today. And this features a ton of enhancements, new features, and a focus on developer experience around how you can better build and test your cloud applications today. For the first session, we are going to have Brian, who will be speaking about how he's gonna speed up your cloud workflows with LocalStack ephemeral environments. And second off, we are going to have Anca, who will speak about how you can develop your AI-powered cloud apps with LocalStack and Ollama. A lot of exciting GenAI stuff, and I'm totally looking forward to that particular talk. But before that, I would like to implore that, okay, so we have got some of our speakers today. So we have got Brian, we have got Anca. Brian has recently joined our team as the developer lead, and Anca has been with us for a couple of years now, I guess. You might have seen her in a few of the past community meetups. Yeah, I know I got that particular time wrong, Anca. So
It's 1.5
apologies for that.
approximately.
Yeah, awesome. How is it going for you folks?
Great, great. I think at some point it may start absolutely storming behind me. You can see like the rain on the window, but that's just typical Florida weather for you. So
And it's 7 a.m. where I am, so
Yeah.
yeah, still dark.
Yeah, you can already see like the whole sleeplessness in Anka's eye. She has just a couple of hours of sleep today. So, yeah,
yeah,
cool, cool, cool. It
We'll
is so
make it
great to
through.
have both of you. Yeah, it is so great to have both of you for this community meetup. And I guess without wasting any further time, let's jump right into what LocalStack 3.7 has got for us. Cool. So as always, if you have to ask questions, if you want to engage with us, you can directly interact with us by YouTube live chat, or else you can join this particular Slido session. You can enter this particular code, and you can directly ask questions to us anonymously about anything around LocalStack 3.7 or LocalStack in general. Or if you're someone who just encountered that particular certificate revoked issue, please put up those questions. We have already resolved that, but we would be more than happy to just walk you through the particular solution that you can use to fix that particular problem. Cool. So yeah, talking about 3.7, this is our new release that we just put out today. So thanks to all our engineers who have been working pretty hard on this, and also to our community members who have made a lot of significant enhancements and bug fixes towards this particular release. If you want to get a quick recap about the release, there is a particular blog where we have documented like most of the major highlights. So I would definitely implore you to go and check out that blog. That would be available to you on the YouTube live chat or the LinkedIn comments. But just to give a very high level introduction about all of the things that we have pushed out, the first one, something that I'm very excited about, is the Lambda debug mode. Please note that this is a preview feature. It will take some time for the whole API surface to be stable, but we just wanted to put out to the community, get your feedback, and understand how we can make the Lambda debugging experience better for you. If you want to get started with this, you can set this particular flag, which is lambda underscore debug underscore mode equals 1. And with this particular Lambda debug mode, it particularly handles execution timeouts, API gateway handlers, and more of these stuff for you behind the scene. You can also set up an additional configuration file that would allow you to set up multiple debugger endpoints for multiple Lambda functions. And this was something that was not supported in the previous LocalStack version. So this is something that you should definitely check out if you want to improve your development and testing experience for serverless applications. Lambda debug mode also assigns specific ports to each function for you. And this is going to be very, very handy if you want to debug your Lambda functions. Second up, we have got Lambda Event Source Management V2 implementation. So if you want to activate this, you can set up Lambda underscore event underscore source underscore mapping equals 1. And this will activate the V2 implementation for you. The difference between V2 and V1 is that this particular implementation has got much improved reliability, performance, and AWS parity. This is also compatible with our Java-based event pattern rule engine. But there are certain limitations that you should be aware about. The first one is that it does not implement MSK event source. It has got no support for persistence yet. And there are a few limitations when it comes to AWS parity. So I would definitely implore you to check out the blog if you want to get more details. Third off, we have got state merging for cloudpods. This was one of the most requested feature when it comes to cloudpods. And now with this particular state merge strategies, you can have different ways which you can basically select around how you want to merge the cloudpod state into your local stack container state. Right now, we have got three strategies implemented. We have got override, which means that we basically clean your local stack container off and we just inject whatever state is available in the cloudpod. We have got account region merge. By the way, this is the default strategy that's available to you. And then we have got service merge. The whole explanation behind this is quite detailed, and this is something that we may not be able to cover in this particular session. So I would just say to go and check the whole information out on the blog, or even better, you can go to the documentation and you can check how these strategies differ from each other and how you can basically get started with them. We have also pushed out some enhancements in the EC2 libvirt via manager. The first off is that you can use this new environment variable, which is EC2 underscore hypervisor underscore URI, to set your libvirt connection URI for the libvirt via manager. And second off, you can now use the user data field in the run instances API to just execute a shell script. So basically, if you want to pre-execute some of the commands when you're starting up your local EC2 instance, you can use this particular feature to do that with the EC2 libvirt via manager. Please note that the libvirt via manager is still in the preview stage. And the best way to help us improve that is just by using it and reporting us any bugs or any potential enhancements that you would like to see in this particular via manager. And finally, just to talk briefly about the SaaS release, we have rolled out a couple of new features in our LocalStack web application. The first one is around support for fetching logs from an existing ephemeral instance. If you don't know what ephemeral instance is, then don't fret. I guess Brian has a complete session to just talk about that particular thing. Second off, we have got extensions which are now embedded into the web application. So if you're using extensions like Mailhog or AWS Replicator, you don't need to start up a local web user interface. You can now use all of that inside the LocalStack web application itself. And finally, the chaos engineering dashboard that basically allows you to inject chaos experiments into your LocalStack setup. Previously, it was using FIS experiments. FIS, by the way, stands for Fault Injection Simulator. But right now, it uses LocalStack's inbuilt chaos API. This gives you much fine-grained control over the chaos experiments that you're launching. And it will also give you a much better experience of managing these experiments right on your local machine. So with that said and done, I guess that was a quick recap of the release highlights. But I guess I'll just hand it over to Brian right now, who will talk about LocalStack ephemeral environments. I guess, Brian, the stage is yours.
Thanks. Awesome. So obviously, I am Brian. I lead developer relations team here at LocalStack, and today I'm super excited to be able to share a new feature. As Harsh mentioned, this has actually been in for a little bit, but it's in a preview stage. So I'm excited to kind of share it for the first time in a public forum like this. So we just released this a few weeks ago. It's called Ephemeral Instances, and I'm going to walk you through how this works and what it is. So I joined LocalStack probably about I guess it was about 2 months ago, and one of the reasons I joined LocalStack was because I thought the project was so ambitious. I mean, I'd been an AWS user, and like those, obviously you probably are, and the whole API of AWS is just so enormous. The number of services seems to grow every day, and so I thought to myself okay, if somebody had mentioned to me a few years ago, oh, we're going to emulate AWS services locally, I would have thought they were crazy. But that's actually what LocalStack did. And so that's one of the things that kind of got me to join. It's super empowering when you get to using local development. It just totally speeds up your development processes. There's no more twiddling your thumbs waiting on deployments. And anybody who's worked with AWS for a while knows that iteration process can sometimes be slow, while you're waiting for your deployments to happen. And LocalStack really changed the game in this respect. So, but of course, our engineers weren't content with just building an emulator. They thought, well, what if we took the local emulator for a cloud environment and put it back in the cloud? And so maybe you're thinking to yourself, oh, that's cool, but why would I want that? And there are actually a number of really good reasons why you would want that. We're going to talk a little bit about those here. A handful of them are better collaboration, providing application previews, easier acceptance testing, validating the state of your cloud pods, or if Docker is unavailable for some reason. So we're going to dig into these reasons just a little bit more for a moment. So the key thing, kind of the cross-cutting all of those things I listed, is collaboration, and that's the key reason why I think you're going to want to give ephemeral instances a try. LocalStack has made, as LocalStack being on your local machine, made iteration and testing really easy, and you could even share the state of your application using Cloud Pods, but sharing a running version of your code required either pushing it to AWS into some kind of temporary environment, spinning up a bunch of resources, then removing those resources, or having somebody who has LocalStack on their machine get everything set up so that they can run that version of your code as well. So ephemeral instances takes all of that difficulty away, makes it super easy to share fully functional running instance of your code via just a link, while also making cleanup trivial. Is you just shut it down and it's cleaned up. So no more like waiting on removing services and seeing that service failed to remove. It's never run into that problem before. uh, so the other thing that it enables is previews. So this to me is like the key feature that is super powerful. And I'm going to show you how this actually works. So you can actually integrate this into your CI processes, like for example, GitHub Actions, and you can spin up a running preview, for instance, on every pull request, so that you can actually do some validation on that pull request via seeing the actual code running. So, as you can imagine, another thing you might do with that is to get acceptance testing. So getting acceptance testing, like on a code change or pull request, it's, from a colleague, it can be kind of complicated if that colleague doesn't have access to LocalStack to pull the changes, to run it manually on their machine. And this gives you a way, even to give a link to a non-technical stakeholder who might need to see a running version of your code. You can do that with ephemeral instances, super easy, allows them to validate the changes in a running version of your application without any setup. So if you don't know what Cloud Pods are, I've mentioned them a couple times here, but basically Cloud Pods are a feature that enables you to save the state of your entire environment that's running on LocalStack. So you can then easily load that state back in in a future, a time that you're running LocalStack, or you can even load up prior versions of that, share that state with your colleagues and for testing purposes, use it in your CI processes and so on. So ephemeral instances makes it really, really easy to load a Cloud Pod into a running LocalStack instance and run validation and testing against it. So there are some circumstances you may encounter where Docker just isn't available, or maybe the person isn't set up with the entire image of LocalStack on their machine. And in these cases, you can actually use ephemeral instances to just get a version of LocalStack up and running in just minutes, less than minutes, really, without the need to install anything at all. It's just click some buttons and you got a version of LocalStack running, and you can deploy to it and use it as if it was the same as your local, the version running on your machine. So we're going to see this in action in a moment. I'm going to do a few things. So I'm just going to walk you through how easy it is to create just an ephemeral instance and start adding things to it. So we're going to add some resources to that instance. I'm going to show you a little bit about how you can connect to it via the command line and be able to upload resources or interact with it the way you're used to on your machine. And then we're going to actually walk through the coolest part to me, which is to create an application preview that's automatically generated for every pull request. So I've got a little bit of a complicated setup here. So I'm going to switch screens, and we're going to go ahead, and I'm assuming you're seeing my screen right now, and we're going to walk through some of this. So I'm going to actually, I apologize, I'm going to show the wrong thing here first. Momentarily, I had the wrong tab open, the wrong environment open in my browser. Apologies. Okay, so I'm in the LocalStack dashboard right now. I'm going to go ahead and I'm going to start a new ephemeral instance. If you see over here on the left-hand menu under LocalStack instances, I have this ephemeral instances tab. So the one thing to understand about ephemeral instances is that you get a certain allotment of minutes that you use against that. So like you determine when you create it, how many minutes you would like this to run. You can go up to like 2 hours. The default is just 10 minutes. So you just give the instance a name. You choose how long you would like this instance to run. I can also immediately here just click, I want to load in a cloud pod as soon as I create it, so I could pull from my list of cloud pods and have that instance already populated with all the resources and state that in that particular cloud pod. I can even install extensions here as well. For now, I am just going to create a very basic like instance using all the defaults and just let this run. So it's going to take just a little bit to run because obviously in this case, it's spinning up the entire environment and deploying LocalStack to it. And then it's going to get everything set up for me. But once it is running, you'll see this page change, and then it'll actually allow me to access that instance. And we're going to start adding some stuff to it. So just give it a moment here to run. Okay, there we go. It took maybe what, like 30, 40 seconds. Okay, just to kind of show you how this works, you can see how many minutes are left in this running instance. As soon as those minutes are up, it's going to clean itself up. All those resources are going to go away. But that's what makes it so easy. You also see that I can shut it down at any point. So like if I chose to run it for a long time and I want to shut that down to save my minutes, I can go ahead and shut it down here. What we're going to do is we're going to go over to the resource browser. For those of you who don't know, the resource browser is super useful. I recommend it even for your local version running on your machine because you can manage all the resources on your instance. Even I don't have my local instance running, but you can see I could access it there if it was running. But I could manage all these things, see what's in my S3 bucket. It's just really, really useful. So I'm going to go ahead and I'm going to go into my S3 bucket. I'm going to actually create an S3 bucket. Sorry. I'm going to call this bucket just my bucket because, that's a really good name. I'm going to leave all the other stuff default. I'm going to go ahead and submit that. You'll see I've now created a bucket inside of my LocalStack ephemeral instance. So I could actually, continue to create assets that way. I can also interact with it via the command line. So I've got a little bit of some help here. So I'm going to set the endpoint. And what I want to do is, oh, whoops, that's not what I want to do. I don't know. Copy paste is failing me here. Copy paste. I'm going to set the URL to be this URL right here. So I want to set the endpoint as that LocalStack ephemeral instance, and then I'm going to run a command. I've already kind of set this up, so it's a little bit easier. But basically, what I'm doing is showing you that you can interact with it the same way you would interact with your local LocalStack instance. That sounds redundant, but so I'm using AWS Local here to actually copy a file into my S3 bucket. But this is instead of copying to my local machine running Docker, I'm actually copying it over to my ephemeral instance here. So if I just kind of refresh this page, we should see, yeah, there we go. So we see that my file uploaded. I'm able to do everything I'm used to doing with AWS Local, which is LocalStack's wrapper around the AWS CLI and things like that. I can actually do that with my ephemeral instance. And I can browse through and see all the running stuff here of this instance and interact with it. I can even do things like I can go ahead, once I have this ready to a state I want, I'm going to click this tab here, and I can actually go here and I can save it to export the state locally so that I can recreate that on my local machine or on another ephemeral instance, or I can save it to a cloud pod and share that with my team. So incredibly useful. And I got that all up and running in just a matter of seconds, really. So I'm going to go ahead and I am actually going to shut down this instance for the moment. Actually, one thing before I shut that down, I want to show you, you can also get to add load an instance via cloud pods right here. So I can actually go into my Cloud Pod and I could actually load into my new instance. That's my ephemeral instance, just as another path into the same thing. So now that we've done that, I'm going to go ahead and shut down this particular instance because we're going to show something else. So as I mentioned before, you can do automatic previews of any pull requests. Really, you could do it on anything, but it's best to set it up like on a pull request. I actually, at one point, just for testing purposes, had to set up for every commit. I ran a preview. You could do that. You would be spinning up a lot of ephemeral instances, but so we're going to do it on PR. So I've got this really simple sample app here. This sample app it's kind of your typical web app running on AWS. It's using S3 to host the web app files. It's using CloudFront, Lambda, API Gateway, and DynamoDB. So it's kind of got all the pieces more or less of a web app. So I'm going to deploy this automatically on a PR to an ephemeral instance and then provide a preview URL to anyone reviewing that PR. So let's see how this is going to work. So I'm going to go actually into my code here. Sorry, got to go to my code editor. I'm going to make a really, really important change to this application. And I'm going to go ahead and I'm just going to, oops, wrong thing. Okay, here we go. Commit. We're going to push that up. And I'm going to go into my project again just to, oh, nope, sorry. Clicking the wrong URLs. Here we go. Sorry. I'm going to get the right URL here. Apologies. Where's my GitHub? We're going to just viewing GitHub here. There we go. All right. There we go. We're in the right place. I'm going to make this pull request. So I'm just going to leave everything as default. I'm going to create this pull request and let this run. As this is running, because it's going to take a little bit, it's using GitHub Actions, and GitHub Actions take a few minutes sometimes to run. It spins up a whole environment and everything, and then it's going to run our command and do all that stuff automatically, though. So I'm going to show you how the code for this actually works. We're going to go in and we're going to say, look at the pipeline that I created. So this is in my .github/workflows, which is where you put your GitHub Actions workflows. You can see that I'm any pull request to main. I'm going to run this actual pipeline. And what I'm doing here is first, I'm going to check out the code. Obviously, I need to actually have that code checked out so I can push it over to our ephemeral instance. And then for the actual preview, we're going to use this setup LocalStack action that we've built for you. So to make this super, super easy, this GitHub token is going to be automatically created by the GitHub action. So we don't need to worry about that. I am going to include a preview URL here. Then the key thing I want to show you here is this preview command. So if you're used to setting up your project locally, then this is basically giving the commands that are necessary to set that project up locally. But now it's going into the ephemeral environment. So in this case, I'm using the CDK. So I'm going to go ahead and install the CDK as well as our local wrapper around the CDK. I'm going to install any dependencies. Then I'm going to go ahead and bootstrap that and deploy it using the CDK. And then because it would provide a preview URL to my ephemeral instance, but I want to override that a little bit and actually provide a preview URL that loads up my CloudFront distribution URL, so you can actually just view the website. I'm going to go ahead and override the preview URL that's being sent to the comment. The only other thing I'm going to note here is that you do need a LocalStack API key. And actually, I'll show you where you get that. We're going to go into LocalStack here. You're actually going to use the CI keys here. And you can create a CI key and use that as your API key. You're going to need to go into GitHub, your GitHub project settings, and into the settings for GitHub Actions. And you can set an environment variable named LocalStack API key as that API key. So that's how that's going to work. So let's go back over to GitHub here. Did that not pull request? I thought I pull requested. Hold on. Let's see. Oh, I did pull request. Sorry. Browser being finicky here. Okay, so you see that it's actually automatically added the preview URL right here. I'm going to click that, and you'll see this is my very, very amazing web application running here. It's again running CloudFront, S3, DynamoDB, Lambda, API gateway. All of that's running on an ephemeral instance that I can automatically preview on off of my PR that was to GitHub. So it's super, super easy to create runnable instances of this automatically, and it's super powerful. It gives you an easy way to get some acceptance testing. So that is it for my demo. I'm actually going to return to my presentation. Okay, so one thing I want to note, as with some of the other features that we discussed earlier, this is a preview release where we want you to kind of give it a try and give us your feedback. We'd love to hear, like, not only any feedback if you run into any issues or there's anything that's difficult, but we'd love to hear ideas you have. Because, I mean, I showed you my ideas of all the ways you might want to use this, but maybe you're like, oh, I'd love to do this. I wish you could enable that. We'd love to hear that from you as well. So I'd recommend either reaching out to us via our GitHub, via an issue if there's a particular problem, or even better, reach out to us via our Slack community. If you're not a member, just join our Slack community and you can kind of reach out to us there. We'd love to hear your feedback. And the easiest way, if you obviously couldn't follow along, I had to kind of compress this into a very quick demo. But if you want to give it a try, just yesterday, I published a blog post that goes through all the steps that I just ran through. It's going to give you the code that you need to run this. It's going to walk you step by step through everything. You can find that on our blog if you want to. If you take a quick moment and you scan that QR code, you can get to it that way as well, and we'll put it in the comments. So that's really it for my presentation. Open to any Q&A here as well.
That was awesome. Thanks a lot, Brian, for walking us through this particular demo. And we do have a few questions coming in. Maybe we can start putting them one by one.
Sure.
So yeah. Okay, the first question that we have got is that, are these ephemeral instances running in LocalStack backend? Is it using AWS behind the scenes?
It is running LocalStack. So it's basically, it's the same LocalStack that will be running on your machine is going to be running inside a container. So yeah, it's going to function just like LocalStack. It's not deploying to AWS, which is kind of like the great thing here is, like, as I said, these spin up quickly and they shut down easily, so you can easily clean them up.
That makes sense. I guess the second question that we have got is that, can we run these ephemeral instances in our own VPC or something similar?
Not at the moment, but that's one of those things that we'd love to hear. If this is something you'd like to see, and then we'd love to hear about what your use case is. I'd say join the Slack community, post that there, and we'll work with you.
That's awesome. And for the final question we have got, are ephemeral instances supported on other CI pipelines? Because yeah, the example was primarily centered around GitHub Actions. So
yeah,
Brian,
actually, you might know better than I do. Actually, I've only tested it with GitHub Actions, so I believe you can use it with pretty much anything, but we just have provided that GitHub Actions kind of what do you call it? I don't even know what you call it, extension or whatever, that makes it a little bit easier to set up, but you can technically do it with anything, I suppose.
Yeah, so definitely. So with the ephemeral instances, we are kind of exposing our backend APIs that you can certainly use with any of the CI providers. In fact, we have published examples on every CI provider that we officially support. So go and check out the documentation for GitLab, CodeBuild, Travis, whatever you're using. And if you're using some other exotic CI provider, I guess the best way to get support for that is just by reaching out to us. And we'd be more than happy to either give you a vanilla implementation, how to use that, or just build out a plugin for you or something similar out of that.
Yeah, sounds great.
Yeah, I guess we are good. Thanks a lot, Brian, again, for just being in this session and presenting such an awesome talk about ephemeral instances. It's kind of surreal to see like how quick you got started up with all of the feature advocates and everything. But with that said, I guess let's bring Anca on the stage as the second speaker for the day. who is going to talk and geek a bit about Gen AI and how she has been experimenting with Ollama and LocalStack. So, Anca, over to you.
Hi. Can you see my screen? Because I can see. Okay, that's it. Okay, so if there's anything technically wrong, please, my colleagues, let me know. Otherwise, we can get started with the second session. And I hope those who are joining are not just waking up and it's not 7 a.m. where they are. So we're going to be talking a little bit about how you can build AI-powered applications locally with LocalStack and Ollama. You, like Harsh said, you probably know me from around, mostly in Europe. My name is Anca. I'm a developer advocate for LocalStack, and I've been with the company for about 1.5 years now. If you want to reach out to me, you can always email me or DM me on X, Twitter. I'm also on LinkedIn, so if there's any question or help needed, please feel free to shoot me a message. Okay, so a little story to give you some context to how I got here. And I want to start off with the fact that I moved to San Francisco recently, about 5 or 6 months ago. And, you know, it's in the famous Bay Area that's known for tech and innovation. So at first it was scary, but then it got exciting. And I thought, oh, look, we have so many opportunities here to attend all the tech events and the meetups. And I thought I'm going to be going to so many cloud events and meetups and Java meetups because Java is generally my programming background. And I thought that it would be all this diversity. But it turns out the reality is kind of different here. Everything is very AI-centric. And you can see these are screenshots of all the available future meetups. So everything is AI, from hackathons to AI for marketers, Gen AI Collective, AI CTOs, meetups. There's even this useless fun AI build-a-thon. So you can see how everybody is very passionate about AI and Gen AI here, LLMs, MLs, and all that stuff. And it was a bit crazy at first and confusing. And I thought, okay, where do I fit into all of this, into this scene? And by the way, I think there's one AI meetup a day in the Bay Area, maybe every other day in the city. So I was trying to find my place here. And then I kind of found the keywords, the local and open source AI developer meetup. Okay, apart from the cuteness, I thought, well, we are local and open source. So this is probably where I would best fit in. And so I attended one of their meetups. It was one of the first meetups that I went to here in the Bay Area because it's conveniently located close to where I live. And what I appreciate about their meetups is that they have these 5 to 10 minutes of demos, and that's it. You come in, you present, not a lot of extra fluff around it. So I'll try to keep it brief. That's quite inspiring for me. So since you're already here, you probably know what LocalStack is. This is, after all, the LocalStack Community Meetup. I'm not going to go through that, so let's dive into the probably unknown part here. By the way, before we go any further, I would like to remind you that if you're passionate about machine learning, we already have a sample application in our developer hub. I think it has been there for almost a year now. One of my colleagues built it. It's using SageMaker. I encourage you to go check it out in the developer hub under applications. Okay, so I want to give you a quick overview of what Ollama is, apart from having a very good marketing team, I guess. Also, the fact that the product is simple and easy to use is also very attractive. It doesn't use 10 buzzwords to describe one feature. So in a nutshell, Ollama is an open source platform or tool that is designed to help users run large language models on their own devices. It is very easy to download and install, and it supports a variety of LLMs. I remember when I first came home from the meetup, from my first meetup, I just picked it up and started using it in 2 minutes. So, and I didn't have much knowledge, so I'm not in the LLM sphere, so to say. It doesn't require any extensive technical expertise, like I mentioned, and you don't have to rely on any third-party platforms or cloud-based platforms or anything like that. And it provides both a simple CLI as well as a REST API, so you can easily integrate it with your applications. And we'll see about how we can do that in about a minute. So at first, it might look a little rough because you first install it on your computer, you install the CLI tool, and this is the first command you will probably run, which is Ollama run, and then you give it the model that you want to use. And you can see it's not exactly cheap when it comes to size, but this is actually the latest, I think it is the latest Llama model. So yeah, you can interact with it like this. You can ask it how to make pancakes, and it will be very accurate. So why do we like it so much? As a developer, you can use it for developing and testing your AI applications locally, which is a game changer because up until recently, you wouldn't have this sort of possibility to do on your machine. And there are a couple of different things that you can do, like, for example, image tagging applications. Say you provide some images to your model, and it will add captions to them, so it's easy for you to identify chatbots. We will see that again in a minute. You can do recommendation systems, content generation applications. The possibilities are unlimited. It's very cost effective to explore AI with Ollama. So you don't have any cloud platform involved. That means you can invest as much as you want into exploring AI because you're only relying on your own hardware to run LLMs. In terms of privacy and security, this is a game changer because you don't have to upload your data or files to other servers or cloud providers. This offers a critical advantage in data privacy regulated environments such as healthcare or finance. There's also the situation where a company might be transitioning from an on-prem setup to a cloud system, and they're still using this dual method that we call hybrid cloud, or they might also be in one of these tightly regulated environments, and then they prefer to have certain information locally, but also use cloud services. In terms of education and research, LLMs are pretty popular in academia, so if you are a student and you want to run experiments and figure out how stuff works, this is ideal for you. If you're also a professor, you can use this sort of tool to teach AI concepts. So yeah, you can see it's very cool, even in this environment. So another great thing about it is that it supports a lot of specialized models, and you can go to their site and they have like this hub where you can scroll through so many specialized pre-built models. And then you only have to do this Ollama run, and you give it the model and it will pull it on its own. You can also provide your own model, but then you would have to go on a different route, let's say. Another great aspect is that it's available as an official Docker-sponsored open source image. And since everybody's using Docker these days, it's pretty much the default. That is really cool. And as of, I think, 3 months ago, It started enabling concurrency by default, which means that it supports parallel requests, and you can also load multiple models. Okay, so let's have a look at the application. What are we building today? If you want to go explore on your own, there is this org that we have that's called, LocalStack samples, and you can just type in Ollama in the repositories. I'm sure it's the only one right now. So let's have a look at the architecture of the application that we will run on LocalStack. So we have an ECS cluster with multiple tasks that will be our Ollama containers. This is for high availability. We have an application load balancer. This will handle the HTTP requests from the client. Our users will interact with a React front-end application that will be served out of an S3 bucket. So everything runs in LocalStack. What else? I have my notes so I don't forget anything here. Right, so the load balancer has a listener that will route the traffic to different targets here. These are basically the IPs of the containers of these tasks within the Ollama service. We have two security groups, one here for the load balancer and one for the service over here, and this one will only allow traffic to come in from the load balancer. And of course, we have our images. We will build them, and we will push them to an ECR repository. All of this is running on LocalStack. And again, at the end, I will show you how everything is running on AWS, the exact same thing. So yeah, this kind of looks a little bit like I built highly secure Hello World apps, but I wanted to make it realistic, so that's why you have all these components involved. For the model, we're going to be using TinyLlama because it's very convenient to use, especially for getting started. And why I chose to use this LLM is because it's compact. That means it has fewer parameters compared to other larger LLMs. It's also powerful because it requires less memory and computational power. This makes it faster. Obviously, it won't be as powerful as Llama 3, but again, this offers some advantages for local development and testing. And because of the fewer parameters, it's also easy to fine-tune. So yeah, this is a good choice for what we're going to be doing. Okay, so let's see it in action. Let's go already. Let's switch to my IDE over here. And we are looking, I hope you can see this, and this is large enough. Okay, so we're going to be looking at the LocalStack folder for now. There's also an AWS folder. You can go check it out yourself in the repository, but we're going to be focusing on this. We have a Docker Compose file. This is how we're going to be starting LocalStack. Brian already mentioned that there's a LocalStack auth token for the pro version. This I have already exported as my environment variable. Let's have a look at the commands that we're going to be running. I'm going to be using AWS Local to create all of my resources. If you're not familiar with AWS Local, this is a lightweight wrapper around the AWS command line tool. So all it does is point the CLI tool to your LocalStack container. And some of the elements here were not present in the diagram, but we can quickly run through and see what's happening. So first off, we have our VPC network, and we're going to be creating two subnets. We will have an internet gateway. and a route table. We're going to connect all of these bits here. We have the security group, the first security group that sits next to the load balancer. We have the second security group that will be in front of the service. We have some authorization here. You can go check it out yourself in detail. I know it's not exactly fun when somebody is just reading commands off a screen. Yeah, we're creating our load balancer, the target group. Everything is here. We're making some adjustments, creating a listener, and then we're going to be switching to creating the repository. We will specify the model that we use. We're going to be uploading our image to the repository and then create the ECS cluster. We have a bunch of roles here. We want to enforce IAM policies to make it more realistic. So we have some policies and some roles that we need to create in order for stuff to work flawlessly. Okay, we're also going to be creating some logs for this. We want to figure out what's happening. We create the task definitions and the service. And then the front-end part where we create the front-end bucket and we copy all of the files that we need from our front-end application into this bucket. Okay, so in this tab here, we're in the front-end folder. We have built our application already. It's ready to go. Let's start our container and run Docker compose. Okay, this might be a bit of an, okay, it's not an issue anymore. I recently updated everything Docker related and it's hanging at some point for some reason. Okay, we can see we're still affected by this certification thing here. Right. So let's run this whole bundle of commands. We're still here in the LocalStack folder. And this will just create all of our resources in the LocalStack container. We can see that stuff is starting to happen here. You can follow along. I also like to keep an eye on the outputs here, just in case there's anything wrong. Hopefully not. I hope the demo gods are on my side. And this will take, yeah, less than a minute. So we have all of these fancy resources created on LocalStack in a very short time. And we can see it here in my Docker desktop that we have our task containers here and our main LocalStack container running. Okay, let's go to the browser and have a look at our front-end application then. This is the one running locally. Okay, and let's ask it a question. You can see I've been testing, so let's ask it what is LocalStack. It's thinking of an answer, and then it starts streaming the response. It's a bit slow because I'm sharing my screen and I also have all of these resources running. So normally without the screen sharing, this would work flawlessly. How do you make pancakes? Right, so you can prompt it for pretty generic stuff, and this is just a model that I pulled off the internet. So it's quite powerful and easy to work with. And this is running on my local machine and LocalStack. We've seen this. This is the URL, by the way, that we are accessing to get to our S3 bucket. It's called frontend bucket, and then the generic LocalStack URL. This is our application running on AWS. It's the exact same thing that I ran, but in this case, I used the plain AWS command line tool. So let's see. I make carrot cake. And this should work exactly the same. So you can see that you can be pretty confident in the parity, and all of this works as expected. All right, so we've seen that. I think we have one slide left or something like that with the conclusion, obviously. Before that, the blog post on this exact application is here. You can go to blog.localstack.cloud and you could just search for Ollama. So in conclusion, you have this powerful combination of Ollama's LLM handling, and when you combine it with LocalStack's power of AWS emulation, it offers a really powerful toolkit to any cloud developer to use locally. So again, you can invest however much you want into building your applications. It's based on your own hardware and your own resources. And that was my presentation. Thank you to the community. And that's it.
That's awesome. By the way, I did notice that the pancake recipe was kind of bad. It was not
Was
actually
it?
performing that well. Yeah.
Oopsie.
Yeah. Maybe it was a
You
tiny
mean
llama kind of doing things in the background. So,
the one in the slide, or the one that I prompted for
mhm.
now?
The one on the live demo.
Oh,
Yeah.
well, I don't know. There's a lot of ways to make pancakes. Who
Yeah,
can judge?
definitely. Mm-hmm. Definitely. But I guess it was a great demo because, yeah, using these tiny LLMs, you can pretty much get started real quick without having to expedite a lot of your local resources. And then maybe you can switch over to like a much bigger model or something that is
Yeah.
more stable for you for your particular use cases.
I guess you
But
can
with that
also
said,
plug in
mhm,
some cloud service that's dealing with
mhm,
LLMs.
yeah, definitely. Like whenever I hear cloud services, I think about services like Bedrock because it basically allows you to plug into a lot of LLMs available out there without having to use any of the singleton providers here and there. But yeah, that was definitely great.
Yeah,
Um,
for now, our users will have to settle for this until we support Bedrock.
yeah, definitely. And I guess that's the first question that actually came up today. So, any plans for Gen AI services in local stack like Bedrock? I guess we got
Oh,
people
this is
excited when we said
actually
SageMaker.
perfect. Yeah, this is actually perfect for you because you were the one who proposed
Hmm.
supporting Bedrock. So
Yeah,
did you get an answer on that or a timeline?
definitely. Hmm. So we don't have a timeline straight up, but this is something that we're definitely evaluating right now. We do have an open GitHub issue, so maybe I will link this down in the YouTube chat, so you can just go there or vote the particular issue, and also let us know if you want to see like a more fully fledged emulation support, or does plain mocking kind of work for you. We're also kind of being a bit cautious because the whole Gen AI ecosystem is kind of moving very fast. And we definitely don't want to create something that we might not be able to maintain like in a pretty long term. So yeah, we have to basically do the balancing act in this particular case. But I'll link the issue over there. So just go there, check it out, and let us know what you particularly think about this. Cool. I guess the next question is something that you can answer best. So, what's the best way to deploy an Ollama LLM on AWS? Any tips?
Well, I guess you can take advantage of the fact that it runs in a container. There are Lambda functions that can be used with a Docker image. You can run it, I guess, in any service that supports spinning up containers. I guess you can pull some models and also run them with SageMaker. I'm not super sure about that. You'll have to try it yourself. So yeah, there are a bunch of options out there.
Hmm.
I chose Fargate because it was easier from my side to demo and also maintain, because I don't have to deal with the underlying infrastructure, and AWS does that for me. So that was my case.
That sounds great. Awesome. I guess we are almost at the end of the meetup today. So maybe I'll take over the slides and yeah, just thank all of you for being a part of this session today. Thanks a lot again, Brian and Anca, for presenting some insightful sessions. And to all our attendees who posted really good questions, who stick with us right to the end, and for being such an amazing part of our community. If you want to see more of local Slack topics, I would definitely suggest to join our community Slack. That's the best place to hang out, ask questions, interact with our team members. And as Brian has already said, give us some nice feedback about some of the features that we have been developing. You can head over to this link to join our Slack community. I guess this link is a bit wrong. It should be localstack.cloud/Slack, not the other way around. But yeah, we'll definitely link this out in the YouTube description, and you can just navigate to that to join our community. Uh, and yes, I guess I'll see you again the next month with some new topics in mind, with some new things to talk about, with some new features to present. So thanks again for being a part of the community. Join our meetup platform if you have not done that, so that you can get notifications whenever we publish like a new event coming up. And yeah, just feel free to reach out to us, interact with us, and send us your feature requests, feedback, or any bug reports or any pesky things that you might be encountering with your local stack setup. I guess I'll stop my yapping today, and maybe you'll see me next month. Hoping so. Cool. Have a good rest of the day, everyone, and I'll see you in the next meetup. Bye, folks.